day. This is the Professor, CBMD PhD. And today's Wednesday, November 22nd, 2023. It is 5:34 and 39 seconds, a.m. Eastern Standard Time. And today's research, cooling glass. So let's jump to it here. The cooling glass blasts building heat into space. Down coating can be applied to exterior surfaces to reduce AC use. Fight climate change. Date November 13th, 2023. Source: University of Maryland. Researchers aiming to combat rising global temperatures have developed a new cooling glass that can turn down the heat indoors without electricity by drawing on the cold depths of space. The new technology, a microporous glass coating, can lower the temperature of the material beneath it by 3.5 degrees Celsius at noon. It has the potential to reduce a mid-rise apartment building's yearly carbon emissions by 10%. The coating works in two ways. First, it reflects up to 99% of solar radiation to stop buildings from absorbing heat. More intriguingly, it emits heat in the form of long-wave infrared radiation into the icy universe, where the temperature is generally around minus 270 degrees Celsius, or just a few degrees above absolute zero. In a phenomenon known as radiative cooling, space effectively acts as a heat sink for the buildings. They take advantage of the new cooling glass design, along with the so-called atmospheric transparency window, a part of the electromagnetic spectrum that passes through the atmosphere without boosting its temperature to dump large amounts of heat into the infinite cold sky beyond. The same phenomenon allows the Earth to cool itself, particularly on clear nights, although with much less intense emissions than those from the new glass developed. It is a game-changing technology that simplifies how we keep buildings cool and energy efficient. This will change the way we live and help us take better care of our home and our planet. Unlike previous attempts at cooling coatings, the new technology developed is environmentally stable, able to withstand exposure to water, ultraviolet radiation, dirt, and even flames, enduring temperatures of up to 1,000 degrees Celsius. The glass can be applied to a variety of surfaces, like tile, brick, and metal, making the technology highly scalable and adaptable for wide use. The team used finely ground glass particles as a binder, allowing them to avoid polymers and enhance its long-term durability outdoors, and they chose a particle size to maximize emission of infrared heat while simultaneously reflecting sunlight. The development of the cooling glass aligns with global efforts to cut energy consumption and fight climate change, pointing to recent reports that this year's 4th of July fell on what may have been the hottest day globally in 125,000 years. And this cooling glass is more than a new material. It is a key part of the solution to climate change. By cutting down on air conditioning use, we are taking big steps toward using less energy and reducing our carbon footprint. It shows how new technology can help us build a cooler, greener world. And this is the Professor, Professor of Space Technology, Advanced Physics, Mathematics, Computer Science, and Leader of Research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have an awesome day.